Before starting the critical path method, you need to get familiar with these certain terms. These are the most common terms in MS Project: predecessor, successor, lag, and lead. You will need to know some additional terms as well, but we will learn these terms when we talk about the critical path method. For now, let's talk about the definitions of these four terms. We have talked about these boxes and the arrow in our coffee example. Here, task A comes before task B, means that task A is predecessor of task B. Task B comes after the task A, therefore task B is the successor task of task A. We have already learned what this representation means in the previous lecture. Task B will start after task A is completed. Does it have to be this way? Does a task should immediately start after another task is completed? We will encounter many cases where this is not the case. For example, task B can start 2 days after task A is completed. Here, these 2 days represents the term lag. Lag is generally shown on top of the arrow. We will see how to add the lag in MS Project in our following lectures. Can task B start 2 days before task A is completed? This can also happen, and this situation will explain our lead term. We have used plus sign to show the lag. We use minus sign to show the lead. Since we have learned the essential terms, we can now start our critical path method calculations lecture. As each term has an abbreviation, critical path method can also be abbreviated as CPM. Before talking about CPM calculations, we should learn the term critical path. A project will cover many tasks from beginning to end. These tasks are linked to each other to create network diagram. For example, this is a network diagram. Here, you can reach from beginning to end by using different paths. For example, you can follow the ABFH path to reach to the end. Similarly, ACDGH is another path. And finally, AEGH is another path from beginning to end. Here, the network diagram has 3 paths. Now, let's assume that one of these paths is critical, and when a task on this path is delayed, all the project will be delayed in the same amount. This path is called the critical path. Any delay on the critical path will delay the due date of the project at the same amount. Therefore, we need to be careful about each task on this critical line. For example, let's assume that AEGH in this network diagram is the critical path. At this point, any delay in any task on AEGH path will delay all the project. For example, if task E delays for 3 days, the project will be completed 3 days after the original deadline. A similar situation applies to task A, G, and H on this line. you can also see the similar issue if a task on the path is completed earlier than the planned date. For example, if task G on this path completes 2 days earlier, all of the project will be completed 2 days earlier. Each project has at least one critical path, but the number of critical paths in a project can be more than one. Activities on these critical path or paths do not have any tolerance for delay. Tolerance for delay is called slack. This term is synonymous with the term float. But since MS Project uses the term slack, we will prefer this term to represent the tolerance for delay. If the tolerance for delay is 0, this means that the slack is 0. In short, slack of the tasks on the critical path are all 0. This is an important piece of information. We will need this information when we determine the critical paths on a network diagram. When we are using Microsoft Project, we will see two types of slack. These are total slack and free slack. Total slack is the maximum amount of delay time on a task that will not affect the duration of the project. So, if you delay a task with an amount equal to total slack time, the due date of this project will remain the same. Total slack value of all the tasks on the critical path are all 0. Free slack is the maximum amount of delay time of a task that will not affect the start time of its successor task. Therefore, if a task has a delay up to its free slack value, the starting and ending time of its successor task will not change. After gaining our prior knowledge, we can now start our critical path method lecture. We have learned most of the terms we will encounter while using this method, and we have also defined the critical path. Critical path method is a method that helps us to find the critical path or paths on a network diagram. If we fully comprehend this method, we can solve the problems that we will encounter in Microsoft Project easily. In this lecture, we will first look at the definitions of forward pass and backward pass, and then we will talk about how to do the related calculations. While doing these calculations, we will be able to obtain our total slack value. This way, we can find the critical paths. Let's say this box represents our task. With forward pass and backward pass calculations, we will calculate each value in this box separately. We write the name of the task in the middle of the box. Then, we write the duration of the task to the upper side of the box and in the center. As you see in this box, there are some abbreviations. Let's see what these abbreviations mean. ES is the abbreviation for the early start term. It represents the earliest start date of a task. If everything goes according to schedule and predecessor tasks have started and completed on time, this term represents the earliest starting date of the task. EF is the abbreviation for the early finish term. It represents the earliest finish date of a task. If a task starts on its earliest start date and everything goes according to schedule, then this task will be completed on the early finish date. LS is the abbreviation for the late start term. This term represents the latest starting date of a task without affecting the finish date of the project. If we start this task at this date, the deadline of the project will not be affected. LF is the abbreviation for late finish. This term represents the latest completion time of a task without affecting the finish date of the project. If you complete this task at this date, the deadline of the project will not be affected. After calculating all of these dates and writing in the box, we calculate the slack value. Here, slack value represents the total slack. Now, let's learn how to calculate these values. Okay, let our task box stay here on the top part. This way, we will not forget what we are calculating. Now, at the bottom part, we have two tasks linked finish to start. A and B are tasks. A will be completed in 3 days and B will be completed in 5 days. We write these durations in the top middle part of our box. Task A is the first task and we start with writing 0 to the early start of this task. Then we add 3 and 0 and write the result in the empty area on the top right side. Therefore, we have calculated ES and EF values for task A. Earliest day we can start task A is the day 0, and the earliest day it can be finished is the third day. Here, starting with the day 0 may be a little bit confusing. We can think it like this. First day starts from 0 and ends in 1. Second day starts from 1 and ends in 2 and so on. ES and LS values are the start of these days. Thus, when we say task A starts on the day 0, we mean that the task starts on the first day. EF and LF values are corresponding to the end of these days. Since the EF value of task A is 3, this will represent the end of the third day. Therefore, the earliest starting day of task A is the beginning of the first day and the earliest ending day of task A is the end of the third day. After this little note, we can continue our calculations. We have calculated ES and EF values of A. Now, it is time to calculate ES and EF values of B. We are entering the EF value of A to the ES value of B. Then, just like what we did in task A, we will add 5 and 3 and write the result in the empty area on the top right side of task B. The EF value of B is calculated to be 8. Up to here, these calculations we have done are called forward pass. When we calculate ES and EF values of each task, the calculation of forward pass is complete. Then, we move on to backward pass calculations. To do that, we are writing the EF value of the last task in the empty area on the bottom right. By doing that, we are calculating LF value. Therefore, latest completion day of task B is the end of the 8th day. Then, we subtract the duration from this value and write the result to the bottom left. If we subtract 5 from 8, we will have 3, which is the LS value of B. Then, we are writing this value to the empty area on the right side of task A. Thus, the LF value of A is calculated to be 3. Now, just like we did in B, we are subtracting the duration of the task from this value and writing the result to the bottom right. If we subtract 3 from 3, we will have 0, which is the LS value of A. Since we have calculated LS and LF values of all tasks, the calculation of backward pass is complete. As you see, we haven't calculated the slack value yet. To calculate this value, we either subtract ES value from LS value or subtract EF value from LF value. Both will give the same result. Slack value for A will be equal to 3 minus 3 or 0 minus 0. Therefore, it is 0. Similarly, the slack value of B will be equal to 8 minus 8 or 3 minus 3. This value is therefore calculated to be 0. Now, let's solve a small example to understand the calculations better. Let's say we have a project with 6 tasks like this. Let's find the critical path here. As we did previously, we will write 0 to the ES value of the first task. The ES value of A will be 0. Then, we calculate the EF value by adding the duration of A. 0 plus 2 will be equal to 2. So, EF value of A is calculated to be 2. We enter EF value of A in ES field of B and D. Now, we calculate the EF value of B by adding 2 and 3. It is therefore 5. Now, let's write this value as the early start value of C. Then, we calculate EF values of C and D and write in the corresponding areas. The EF value of C is 9 and EF value of D is 7. Now, we will write the EF value as the ES value of the following task. But we have two EF values. C has 9 and D has 7. Which ES value should we choose for E? What do you think? We should choose the larger value here. So, ES value of E is 9. We are completing the remaining forward pass calculations in the similar way. Now, it is time to do the backward pass calculations. Since the last task is F, we are writing EF value of F as its LF value. The LF value of F is 13. If we subtract the duration of F from this value, we can obtain the LS value of F. Therefore, the LS value of F will be 13 minus 3, which equals to 10. This value is also equal to the LF value of E. The LF value of E is 10. If we subtract the duration of E from this value, we can calculate the LS value of E. The LS value of E is calculated to be 9. This value is also equal to the LF value of both C and D. We will do the similar calculations for tasks C, D, and B. Now, we will find the LF value of A. But which value should we select? LS value of B, which is 2, or LS value of D, which is 4? What do you think? In forward pass calculations, we choose the largest value, but in backward pass calculations, we should choose the smallest value. Here, the LF value of A is therefore equal to 2. If we subtract the duration of A from this value, the LS value of A is calculated to be 0. Since we have completed our backward pass calculations, we can move on to slack values. Slack value is calculated for each task by either subtracting LS from LF or ES from EF. Since we have calculated all values, we can determine our critical path. To do that, we need to mark the tasks having 0 slack value. When we link the tasks with 0 slack value, we find the critical path. Since slack values of tasks A, B, C, E, and F are 0, these tasks are on the critical path. At this point, critical path is A, B, C, E, F. As you see, we have to do a lot of calculations even in a 6-task project. And these calculations can take a lot of time. If you have thousands of tasks, this will take months or even years, right? Here, Microsoft Project comes to our head. All we need to do is to enter the related information for each task in Microsoft Project, and the program will do the calculations in milliseconds. You will probably ask why we need to learn these calculations if the program is doing everything for us. The reason is, if we know the underlying logic of the critical path calculations, we can better interpret the results calculated by Microsoft Project. These calculations will become important if we want to postpone or retract the schedule. Now, we have the necessary infrastructure for Microsoft Project. We can start to learn the program. So, I will see you in the next section. Thanks for watching.